The Elixir of Love. That looks like a chromatogram, Lynn announces as she glances at a printout on the lap of the guy sitting next to her on the plane. Yeah, it is, Rick Feldhoff responds. Rick, a biochemist on the faculty of the University of Louisville in Kentucky, is flying home from a scientific conference on proteins. Lynn goes on to explain that her lab group is trying to isolate a protein pheromone from a gland on the chin of a salamander. Tell me more, Rick says. By the end of the flight, Rick and Lynn agree to collaborate on the identification of the salamander pheromone. The unusual circumstance of a gland dedicated to pheromone production hooks Rick on the collaboration. What? You collect salamanders at night in North Carolina? Lynn explains to Rick that she and her students spend a month each summer at a biological station in western North Carolina, making daytime and nighttime forays into the surrounding mountains to collect salamanders for pheromone research. The idea of field work is foreign to Rick. He does biochemical work with frogs and rats, but he orders them from a biological supply company. Lynn goes on to explain her procedures for removing chin glands from the males, making gland extracts, and then testing the efficacy of the extracts in courtship using an observational bioassay that she devised. Pressing Lynn for details on the extraction procedure, Rick proposes improvements that should increase pheromone yield. Lynn suggests that he join her group at Highlands Biological Station the next summer to try out his improved protocol. Rick and his biochemist wife, Pam, become collaborators on the project and work with us at the biological station and in the field for the next 20 years. Although Lynn's first effective extract is known in the lab as the Elixir of Love, once biochemists join the team, the extracts are given boring descriptive names like PRF, plethodontic receptivity factor. Hey, what is that? Asks postdoc Richard Watts, who is riding shotgun as I drive us back to the biological station after a night of collecting salamanders. Ahead in the headlights, a cantaloupe-sized ball of fur rolls about in the middle of the road. A weasel chases a rabbit onto the road, overtakes it, and is now trying to deliver a fatal bite to its throat. By the time we get out of the car with our flashlights, the weasel has run off, leaving his lifeless prey behind, its brown eyes staring up at the sky. We often see foxes and opossums on the road in the early hours of the morning, but we've never seen anything like the weasel kills rabbit spectacle. Richard, our red-haired, energetic Australian postdoc, did his doctoral work on the evolution of hemoglobins. Field work is a new and pleasurable experience for Richard, as it is for Rick and Pam. Our research team discovers that the mountains are alive with strange plants and animals. In the course of our salamander work, we savor all kinds of encounters with the indigenous plants and animals of the Blue Ridge Mountains of western North Carolina. We learn to recognize Dutchman's pipe, a vine that climbs trees. The shape, color, and scent of the pipe-like flower lures insects inside the pipe to pollinate the flower. We also watch male balloon flies fly through the forest carrying nuptial gifts for the females. The gift consists of a silky wrapping around a dead insect. The male presents his gift to the hungry female to distract her while the copulating male transfers his sperm. At night, we focus on capturing the salamanders we need for the experiments ahead. The nights are long and tedious as we strive to catch our salamander quotas. Back at Highlands, we unload our bags of live salamanders into our basement lab under the Nature Center and collapse into our beds in Valentine House. The town of Highlands is a resort community situated on a plateau high enough to offer relief from the summer's heat to tourists from Georgia and Florida. The biological station has been in operation since the 1930s, offering summer courses to college students and lodging to researchers. Our group occupies most of Valentine House, which had been donated to the station by a local family. In the morning, we drink our coffee on the front porch, watch butterflies visiting the flower beds in front of us, and two pregnant garter snakes, one brown, one gray, as they crawl out from under the rocky porch to warm themselves in the sun. After coffee on the porch, we make breakfast in the kitchen. Trudging over to the basement lab after breakfast, we set up each salamander, Plethodon shermani, in its own labeled plastic shoebox. The basement has thick concrete walls that keep it cool all through the summer. On courtship nights, we set up stacks of boxes in a semicircular array so that 3 or 4 observers can observe and record ongoing events. Each box contains a salamander and a female and a male salamander. Chin glands have been removed from all the males, and their chins have healed over the course of a few days. Once courtship progresses to the pheromone delivery stage, Lynn uses a pipette to carefully apply a small drop of fluid to the female's nostrils. This application stimulates pheromone delivery by the male, but with an important difference. In half the courtship, Lynn applies courtship extract. In the other half, Lynn applies a control solution which lacks pheromone. The observers then measure the time from experimental delivery to spermatophore deposition by the male. In later data analysis, Lynn compares the experimental and control groups to determine whether the pheromone extract speeds up the time to deposition, reflecting the effect of pheromone extract on female sexual motivation. This protocol sounds simple, but in practice it requires laborious scorings of courtship time in dozens of staged courtship. Nevertheless, the protocol provides a way to assess whether an extract of the entire pheromone or any of its components is biologically active. The success of the project depends on teams of professors, postdocs, and students at each stage in the experiment. Collecting salamanders in the field, setting them up in the basement maintenance room, surgical removal of glands from the males, biochemical separation of the pheromone components, testing for courtship effects of the components, and finally, returning the live salamanders to the field. The teams consist of professors, postdocs, graduate students, and undergraduates from Corvallis and Louisville. We all live in Valentine House and rotate the chore of cooking dinner each night among us. At dinner, we laugh about the foibles of the day and discuss the design of future experiments. After dinner, we watch rented videos on the house television, or if it had rained, head off to a neighboring mountaintop to collect salamanders. We share a spirit of scientific pioneers, honing and pushing forward the cutting edge of the forward thrust in pheromone research. As the molecular work and bioassays continue, a picture emerges of the courtship pheromones and their effects on the female. The pheromone turns out to be a cocktail of 3 very different proteins. Each of these proteins has been rapidly and perpetually evolving for millions of years, presumably part of a coevolutionary race driven by protein receptors in the female. When the pheromone is transferred to the female's nose by the male, it activates olfactory receptors in the female's nasal cavity. From there, the signal goes to the female's brain, and in some way encourage her to mate with Mr. Right. The salamander story I've just recounted is fascinating in its own right, but what is the possible relevance that it could have to the human condition, U.S. Senator William Proxmire might ask? To answer this question, we must delve into the realm of speculation. It is conceivable that Mrs. Proxmire reacts to the smell of U.S. Senator Mr. Proxmire when they get in bed together, by way of a neurological pathway similar to the one in salamanders. See the episode called The Dustbin of History. Well, it's something to think about.